Hello everyone, I hope you are doing well. Welcome to this demo of a complete real-time data streaming solution using Apache Kafka, Spark Streaming, and Change Data Capture with Debezium. I am excited to show you how this solution processes data in real time and updates a dashboard automatically. So let's start with explaining the solution architecture. Here we have a PostgreSQL database that records the transaction of the client. Using Debezium for change data capture or CDC, we monitor any change in the database and publish them to Kafka topics. Kafka acts as our message broker, distributing data across its broker. The consumer service, powered by Spark Streaming, subscribes to Kafka and processes the data in real time. Once the data is processed, it is stored in a MySQL database serving as the storage layer. And in the same time, we have a notification service that sends an email to the user, to the business user actually, told him that a new data is coming and processed successfully, and the dashboard is updated successfully also. So now let's see the demonstration, and I will start by demonstrating the CDC mechanism with Debezium. Here I have my Docker containers running. As you can see, the key components are running Debezium. For CDC or change data capture, we have Kafka brokers, Zookeeper, and the Postgre database. And also we have control center to monitor our Kafka topic and the Debezium UI to create the Kafka connector and so on and so forth. So now I will demonstrate the CDC mechanism. I will insert some data in the PostgreDB and we will see if the Debezium capture the change and publish it to the Kafka topic. So I will take this statement, SQL statement, but I will change just the ID. Let's see, 1. I will copy it. I will paste it here. As you can see, a new record is inserted. Now we have 3 records, I guess. Yes, this is the new record. And now let's go to the control center and we will see if the record is captured by Debezium or not and publish it to the Kafka topic or not. So we have this topic, message, partition 0. We can see here that and we can see here the record is published successfully to the Kafka topic. The ID is 1. The ID is 1, the brand and Phoenix, screen size, RAM 2, ROM, dual is the same record that we are just inserted to the PostgreDB. So the Debezium capture the change and publish it to the Kafka topic. Now let's explain the Spark streaming process, the consumer service actually. The Spark will subscribe to these brokers, and if a new data is published to this broker, it will capture it by Spark streaming and it will process it in the real time, and the processed data it will be stored in the MySQL database, and also we will see a notification that's sent to the business user. So let's see this. By the way, this is the connector that we have created in the Debezium. It will capture the change in this database, smartphone DB, in all the table in this database, smartphone DB. It's something to configure. We can create a new one. We can select the database, Postgres, next, and just fill in these parameters and click validate, and you will create a connector to the PostgreDB. In my case, this is the connector, smartphones con. So for the Spark streaming job, I have already run the application, and also to test the streaming, I have this script that inserts the data into Postgre each 5 seconds, and Spark will capture the data after publishing to the Kafka and process in real time and store it in MySQL DB. I had already inserted a lot of data in PostgreDB. That's why we have these data in MySQL DB. So now let's see the Spark job. As you can see, the statistical summary is updated successfully. If more than 2 records published to the Kafka topic, a notification it will be sent to the user, told him that a new data is coming and proceed successfully, and the dashboard is updated also successfully. In the meantime, we will see the backend of our dashboard. It's developed with Spring Boot app. It's a classic application with a classic architecture. We have the controller, the DTO, the mapper, models, and also we have the services, interfaces, and their implementation and their repository. And also in the control we have these endpoints to send these DTO. This is the DTO, contains some statistics, total phones, the max price, the max screen size, the max RAM, the max battery capacity, and other statistics that we will explore in the dashboard. In the React app, we have the component, horizontal bar chart, the KPI, the stack, the histogram, and also we have the services, and it will fetch the data from these endpoints. So let's go back to the Spark job, and we will see if a notification is sent to the user or not. Actually, no, we have just one batch processed, so we will wait to the next batch and we will see if a notification sent it to the user or not. As you can see, email sent successfully. Let's check it. Here is the email. Hello Ayman, new data has been successfully processed and stored in the smartphone database. Please check the dashboard using this link. I didn't host the application, that's why we see this link localhost. In my case, I configured the application to send the notification after 2 records coming from the Kafka topic. But in the real world scenario, actually after 1,000 or 2,000 records, we will send the notification to the business user. So let's see the dashboard. This is the dashboard. So in the header, we have real-time smartphone data analysis dashboard as the title, and we have also the last update. And also we have the KPIs, total phones, displays the total number of phones processed by the system. Also we have max price, shows the maximum price of a smartphone in the data given in Moroccan dirham, MAD. Also we have max screen size, the largest screen size recorded in the dataset. Also we have max RAM, the smartphone with the highest RAM capacity, the same for ROM and the same for the battery. And also we have some charts, total phones by brand. This bar chart shows how many phones are available for each brand in the dataset. For example, we have 8 phones for Nokia. The same for max RAM per brand. For example, for Nokia, we have the maximum RAM is 7. As you can see, the dashboard is updated successfully. And also we have max battery by the brand. For example, for Nokia, we have 3000, means 3 ampere or 3000 milliampere, and so on so forth. We have also other visuals that you can explore by yourself. And the important thing is that the dashboard is updated in real time. And we can wait for more data to be processed to see if the dashboard updated or not. By the way, this kind of dashboard can be very useful for business users or analysts who need to monitor trends in their smartphone market, evaluate top performing brands, and make informed decisions based on real-time data. As you can see, the data is indeed updated successfully. The KPI of total phones is updated successfully. So to recap, we saw how the on-chain systems work together, from data ingestion with Kafka, real-time processing with Spark Streaming, change data capture with Debezium, and real-time processing with Spark Streaming, storage in MySQL, email notification, and finally real-time dashboard using Spring Boot as the backend technology and React as the front-end technology. Thank you for watching. Hope this demonstration gives you a better understanding of real-time data processing solution.